Canted valves on a Windsor? Greetings and welcome back. In part 1, we installed a forged crank into our 347's dart block, including forged 11.5 to 1 pistons and H-beam rods. We dialed in a high-lift solid roller cam and finished up the bottom end with a dry sump. And to push this engine past 7,500 RPM, I'm going to install my set of Kazi Racing CNC ported canted valve P38 heads. I'm also going to install a Jezel shaft rocker system, double taper push rods, a hand-ported Edelbrock Victor Jr. manifold, and a custom carburetor built by AED Performance. Unlike almost every other Windsor cylinder head, this has canted valves. And that was something I was really looking for, a la 351 Cleveland Boss 302. These are the only heads I could find that fit in my budget at the time. Had I known what I know now, I may not have got these, but the jury is still out on this. I'm not sure if they're going to live up to the potential that I hope they will. So why did I pick canted valve heads? Well, they flow a lot better, that's why. A typical small block Windsor, the valve opens like this and stays pretty close to the cylinder wall. However, on a canted valve head, it actually pushes away from the cylinder wall. That lets it breathe a lot better, which is a lot like a 351 Cleveland or a Boss 302. Here's what we had before. We had crane roller rockers, 3/8 diameter push rods from Trend, and to stabilize everything, a stud girdle from Kazi to fit the P38 heads. On a chassis dyno, and also some videos I saw on YouTube, that there might be some instability in this design. So that's why we're going away from this and going to something a little bit better. On the Jezel shaft rocker assembly, there is a machined piece of metal that sits on top. So this all has to be machined flat. And according to the machinist, there was a couple areas he couldn't quite get down far enough on. But after checking with Jezel and the manufacturer of the heads, they said that's pretty typical, is not to worry about it. Also, depending on the how much is taken off, you typically need some sort of shims to get the stand height correct. And I've already done this once, but I'm going to go through it again. Also, I took great care with the cylinder head bolts on the top here to make sure they weren't sticking up too high, because you don't want the stand to be rocking on one. And each part of the stand has machining for the roller rocker shaft, and because this is a canted valve or splayed valve engine, these are not going to be perfectly straight across. They're actually going to be a little bit of an angle to match the stem on the valve. When most of us build an engine, we typically settle for a 5/16 push rod. This is a 080 wall, which is okay. It's not great, but I want something a little thicker. The last engine I had, I used this 3/8 push rod. And then I had a choice to going up to this 7/16 push rod. That's what I'm going to use. It also has a 165 wall, so it's a lot thicker. It's also quite a bit heavier, but it's a lot stronger. and less chance of it deflecting or bending. And in the end, what I went with is what's called a double taper. It starts at 5/16, gets to about 3/8, goes up to 7/16, and then back down again. It's also a 165 wall, and it's also relatively heavy, but it's the strongest thing I could get. And because of that, there were certain lifters I had to get as well. On the left are the original comp cam roller lifters I was using, and on the right are the ones I'm going to use now. And here, let me show you why. These are the push rods I'm going to be using. I actually have 3 different lengths because of the way it measured up, but I could have gone with this single taper 7/16 push rod, but it's just a little too wide right in here, and that was where the problem was in the cylinder head. So I went with the double taper. So on the left I have the comp cams roller lifters, and on the right I have the BAM lifters. These BAM lifters have an offset in them, and the comp cam lifters do not. Let me show you what that means. If you look straight down into the top, you can see that the cup where the push rod sits is right in the center. On these, they're offset, both sides. I think it's 0.180 inches from center. And what that does for me is gives me a little more room on the angle, because it's not quite in the center. It's over a little bit. And another benefit I have with these is because they're not as deep, there's also more room for this to move over towards the edge before it starts to interfere with the housing. When I ordered these, one of the things that was important to me, of course, was it's made in the US, but also that there is a DLC bearing. What that means, DLC is diamond-like coating, and that's a treatment they put on steel to make it super hard. The piston pins in my engine have a DLC coating. And where it's done here actually is because this is not a roller bearing, but actually a bushed bearing. It's roller, of course, but it's still bushed in here. It doesn't have any needle bearings. So inside it has this steel bushing, which has the DLC coating on it. So I don't have any worries now about any needle bearings coming loose on a roller and getting into the engine, because that is typically completely disastrous. I don't think I've ever had to work as hard as I had to on these cylinder heads. What a pain in the backside. I had to modify all the bores for the push rods, and that took not only 2 trips to the machine shop, but then some massaging on my own with a die grinder to get the push rods to clear. Besides having to get larger push rods, I had to get 3 different lengths. And those push rods are all color-coded, so in case I pull one out, I know which bore it goes back into. The offset lifters, in order to get by the ports, as you can see, this is pretty close right here. If you were to look through the aluminum in the cylinder head, you can see how close this gets to the intake port. And on this side, how close it gets over towards the water jacket. But that's all done. So this thing's ready to go, and everything checked out. Valve clearances are good. The clearances on the push rods and the bores are good. What a big, big headache this has been, and it's taken so much time to get the right parts and to get it all done. But finally, this thing is ready to move forward. Well, surprise, surprise, the joke's on me. I had an intake manifold sent out for porting. Actually, it was run through the machine shop. They did all the work. And I guess they used this gasket, which lines up perfectly with my Cossi P38 heads. When I come over to the manifold that was ported, first of all, let me show you the work. It's really top notch. It went down and did everything, and even built up or kept this area high, as I understand it, so that the center ports don't flow quite as fast as the outside ports in order to maximize airflow. But when I went to line up my gasket, this is what it looks like. So I got to get a hold of these guys and find out what happened, because the scribe marks, they're there. It's all scribed. But was I supposed to do the port matching? I don't think so. Well, it appears I may have overreacted. I just got an email from the manifold porting guys at CFM South, and they've told me that they're happy to finish this at no additional cost. And what we're talking about is the stripe marks that I found on the manifold. I thought this wasn't finished, but they said that they'll go ahead and do it for me. I just have to do a little bit of setup and send him the manifold with some markings on the gaskets that came with it, and send him the gaskets as well. So let me get going with that. But basically, it looks like I was left out of part of the conversation, or possibly even maybe more likely is that I wasn't paying attention when the engine builder provided me with a manifold. He might have given me some instructions on how to set it up, and I was a little overwhelmed with everything and maybe missed that.
I don't get it.
I don't get it. I don't get it. I don't get it.
I still don't get it.
But in any event, that's what I'm going to set up today. I'm going to go ahead and take the manifold, set some gaskets on the heads, put the manifold down, clamp it down, and make some marks. Here's my Holley XP. It's a 750 CFM. This is what I ran on my last dyno session. The machinist who did all the work on my engine recommended that I check into another carburetor, something slightly larger. So I decided to go with this. This is an AED. I believe it's around 800, 810 CFM. This carburetor was custom built based on the components I'm using in my engine and my intended use for the car. We'll try this one first at the dyno session, and if it doesn't work out, we'll try the other one. Part one, you probably saw me cleaning out this pan and putting it back on. I wanted to make sure there wasn't any pieces of the piston floating around anywhere, and luckily nothing was down here in the screen inside the dry sump, and I couldn't find anything in any of the passageways when I took it all apart. Also, I went through each and every line in the car, including the dry sump tank. So everything in there was taken apart, cleaned up, blown out, and then sealed back up. So there shouldn't be anything floating around anymore. So here's how it works. Each one of these sections is separated from the other. So there's these little valleys inside. Each one of these valleys has oil that gets pulled in through the channels, pulled in by the pump here, pumped out there. That goes to the top of the dry sump tank in the back of the car, which is right here. It goes in here, and then it gets pulled out of the bottom of the tank, and from there, it comes in here. So from the dry sump tank, it comes through a dash 16 or 1-inch line, goes through here, it's pumped up through this dash 12, and the dash 12 line goes through my oil cooler and my 2 oil filters, and then finds its way back to here, which goes directly into the engine. And if you're wondering about the two ports in here, one of which normally goes down to the oil pump, the stock oil pump position, that port gets blocked off by this cap. The only place oil can go when it gets to here is into the oil galleys and not back down into the pan. One of the unexpected benefits of having a dry sump like this one is that the oil pump is not driven off the distributor. So there's no distributor shaft to drop down into the engine. And I don't have to line anything up on the bottom because there's nothing there to line up with. I put a bronze bushing on this, and I probably didn't need to because the only thing that is being spun off the camshaft is this, no oil pump. So I'm going to go ahead and install this, and after reading the directions, I'm not sure it really matters what direction I go in because it's all electronic. Right there, you can see there's a pickup underneath it, this thing. I want to get that kind of in the area of the notch, and then we'll do some final adjustments, but I just have to add some voltage first. So from the distributor, come back, you have one lead, which goes into the DIS ignition system box. I just took this out of the car. There's only 3 wires I need to be concerned with at this point. One is the clean power from the battery, and the clean negative from the battery, in my case, or ground to the chassis. And I'm not going to need this tack, which is the gray wire, and this red wire, which is the on or run position. So I'm going to connect the 2 reds together, put power to those, and then ground this to my power source as well as the engine block. And that should help me pull up some LED lights on this that are needed to get it synced correctly. Okay, I'm using a battery charger to set to 2 amps. Hopefully that's not too much. Let's see what happens. Okay, the directions say to turn this counterclockwise until the crank light goes off. Right there. And then come back until it comes back on. Right there. Right there? Now right there? Okay. That's where it needs to be so the computer can see it. And that's it. That's all that took. Really easy. I was just getting ready to mount all the accessories on the front of this engine when something occurred to me. This engine is not going to go back in this car yet. It's going to an engine dyno. So because of that, I think I'm going to take off my dry sump pump, and I'm not going to mount any of the accessory drives. I just don't want any of that stuff sticking out when I'm, putting this thing into the back of my truck on the end of a chain. So I'm going to take that off, and I'm going to button this thing up. And then, the next time you see this engine, it'll be at the dyno shop. Hopefully. Wish me luck. Thanks for watching.